I'm going to give you a short introduction about debugging tools. So after that course, you will go back home and you will probably spend a lot of time comparing the different compilers, choosing the best compilation flags and the option that you can use with APRun. You will submit your job, and unfortunately, your job will crash, or even worse, you won't get the result that you are expecting to have. So in that case, what can you do? The only thing you can do is use some of the available tools to find what's going wrong inside your code. And one of them is TotalView. But before I begin, just out of curiosity, how many of you never used a debugger before? Okay. And how many of you used TotalView before?
Never or ever?
Never used a debugger. Never.
Well, the most complicated one was putting write statements.
Well, that's not what we are talking about. And how many of you managed to debug an application without using a debugging tool, like by putting printf statements? Okay. So I guess we should continue. So TotalView, it's a debugger. It supports Fortran, C, C++, MPI, and OpenMP parallel codes. And if you look closely, whatever programming environment you will load will automatically load also TotalView by default here. And by the way, here you have the version of the MPI, Cray MPI library, just in case you want to know. So TotalView also support different kind of other languages like UPC and Core Fortran, but I'm not going to talk about that today. TotalView is sold by a company called Rogue Wave Software, which is selling also other tools, and Sadaf already talked about them. One of them is called Thread Spotter, which is more some kind of performance tool that will show you the performance of your threads. So we are currently doing the evaluation of that tool, and maybe we will buy a license for that. You will see that TotalView also includes memory escape, which is the memory debugging part of TotalView. They have also something which is called reverse debugging, which is some kind of time machine which allows you to go back in time from the point where your execution crashed and go back reversely. So it's called Replay Engine. You have also one little utility which is TotalView Remote, which can be very, very useful when you want to use TotalView from your office, but you have a slow internet connection, and in that case, it will allow you to use TotalView in a user-friendly way, and that's what I'm going to use. And the last thing is that TotalView also supports CUDA debugging, so that's debugging on GPU, but there will be a course dedicated to that, and there will be also a course in a few months dedicated to debugging, where we will invite some developer from TotalView, and you will be able to ask difficult questions to them, not to me. So let me give you an overview of the tool. So this is the main window of TotalView. It's divided in different panels. So the most important panel is probably the source panel where you can see your source. And on almost every line, you have these little boxes that you can click on, and that will set the breakpoint. So the breakpoint is you asking the debugger to stop the execution of your application so you can be able to examine the value of some variable. And you can set as many breakpoints as you want, and hopefully it will let you find where the cause of the bug is in your source. At the bottom, you have the navigation panel. So it will mainly show you the list of what action point, because you have two types of breakpoints. You have the breakpoint where the code is just stopping, and you have also watch point. I'm going to explain that. Then you have the processes panel, where you can see all the different MPI ranks. And then you can navigate from one rank to the other just by clicking on the blue box. The first one is the rank of Epiron, and you can just safely ignore that one. And you have, in the case of OpenMP plus MPI hybrid code, you have also the list of threads. You have also the 4 little buttons here on the right, so you can click on them and move from one process to the other, or from one thread to the other. Actually, you can also click directly at the top here. So here, I am on rank 0, first thread, and if you click on it, you will move to the next thread or the next rank. And you will have also another window which will give you just the plain list of all the processes running. You have also the two panels here. So the first one on the left is the stack trace panel, where you can see the call tree of your execution. So it will let you know what kind of calls have been made. So you start from the main program, and then you call the first routine, the second routine, and then you go down to the routine where the bug is. And on the right, you have the stack frame panel, which will show you a list of registers or even variables. Okay, this is the main root window. You have mainly two windows with total view. I don't really use that window, but sometimes it could be useful. It will show you, again, the same kind of information. So here you have the rank ID, and if you click on the rank, you will get all the thread ID relative to that rank. You have the status of the process. So in that case, B means we are in a breakpoint. R means we are running. And you have more information on where, in which source file you are. Okay, so as I said before, it is useful to set breakpoints in your source code where you want the execution to stop. But sometimes, if you have a loop, for example, it will take a very long time to step into the execution for each indices of the loop. So instead of putting a breakpoint, you can make your execution stop depending on one stopping condition, which is, in that case, I don't know if you can see it, but if E equals 27, then stop. So that's a different way to stop the execution of your code. And of course, now this is the most interesting thing, because when the execution is halted, you can click on the different variables, and it will pop up one window. So that's called diving in, and it will show the values of your arrays, and you can even do a chart of the array. So in that case, there is probably something wrong here, because the values here are just like falling down to 0. So it really depends on your code, but I will do a very short demo.
It looks to me like it shows the variable values, but not the variable names. It's just the numbers from.
So in that case, the x-axis is the number of ranks. That's the ranks here, and that's the value of the. But let me show the example. Okay. So of course you need to forward the X display. But as I said before, I will use the remote display client, which is a little utility that is available for Windows or Macintosh or even Linux in my case, that will allow you to use TotalView remotely. So of course you don't have to use that, but if you think that your connection to CSS is too slow, that's a good way to make things happen faster. So I don't know if you remember, but you have your workstation, and then you have to connect to the login node of Palu, and then from the login node you connect to the compute node in an interactive session. So that's why we have two steps here. The first one is connecting to Ella and then connecting to Palu. So let's try. So it will launch TotalView by default, but in my case, I want to go in an interactive session. So here, I just want to show you how we can examine data in a simple way. So I'm going to use a serial code, which means no MPI, no OpenMP, but the next demo is a parallel code. So the first thing that you want to do is loading the programming environment. And then in that case, as it's not parallel, I can run on the login node with TotalView. Oops, forgot -G. Then, hopefully, that should work. So the first thing here is that TotalView is asking you if you want to have memory debugging and replay engine. We don't have the license for replay engine, so that's not going to work. And memory debugging, I keep that for the next slide. So you just say echo, you just say OK, and here you can see the source. So it's a very simple example. I don't really know what it's doing, but I'm setting a breakpoint here because I want to visualize the content of that matrices V. So let me just run to that line, just click go. And you see the execution is at breakpoint number 1. And now I will click on the properties and I will change that breakpoint to an evaluation point. And in that thing, I will say I want to visualize that part of the array and that part of the array. And we will iterate and we'll see what will happen. Oops. So of course that crash. start again. That's the demo effect. Okay, so okay, so I click on Go, and as you can see, it creates two windows. So in order to be able to see what is the value of the index of the loop, I just dive, and then we will just iterate. So in that case, you can see that I'm moving from 0 to 1, etc. So if you know what your code is doing, you should be able to detect something wrong if something is wrong. Okay, and when you're done, just kill, exit, and that's it. Is it more clear now? Is it? Yeah, okay. So you can do, of course, the same in the case of parallel code. So the idea is that you click on the variable you want to see. Actually, you right-click, and then you say, I want to see the value of that variable across processes, so across MPI ranks or across threads. And it will show you for, in that case, rank for the 4 MPI ranks, the value of my ID, which is actually the rank. So it looks fine, it's from 0 to 3. And there is also, as we said before, the memory debugging part of TotalView. So when you compile your code with -G, this is not on by default. You need to load an extra module, which is called XT-mem TotalView. And if you don't compile with that module file loaded, then you won't be able to see the memory usage of your application. So this is called memory escape. It's part of TotalView, so it will give you information about the usage of your application. But every time you can trace your usage just by setting breakpoints at the beginning, at the middle, and at the end of the execution, and you will see the evolution of the memory usage. It's even more powerful than that. It will show you memory errors like memory leaks or memory corruption when you try to write on a piece of memory which is already allocated. You can also compare the memory usage, so between different points inside your code, but you can also compare different jobs just by saving the state of the memory into a file and then rerun another version of your code and compare it with the previous execution. And in some case, you can compare one version of the code which works fine and one version of the code with a bug, and maybe it will help you to find where the problem is. So that's the memory leaks part of Memory Escape. I'm not going to say much about it because it's kind of complicated, and I will let that to the developer of TotalView. But you should know that in that window, if that's the view of your memory, and if you click on the red part, which in that case show that some memory is leaking, it will show you, it will let you see from where in your code your memory is leaking, and then maybe you can take some action to make it work better. So that's time for demo. So I will do the demo, and hopefully it will work, but you can follow the slides, and there's very little chance that the slide will not work. Okay, so you already know that test case is from Roberto. So let me do a make clean. So with TotalView, you can debug MPI and OpenMP code at the same time. So in that case, that's a very simple example where you have MPI part, the OpenMP part, and then you just print your rank, your thread ID, and your core ID, and also the name of the compute node on which you are running, and then you're done. So the best way to do that is first to load a programming environment. In my case, it's the GNU compiler, and then you compile your code, and you just ignore that warning because that's not very important. And then you go interactive. So in that case, I will use two compute nodes. And let's try to run it just without TotalView to see what it's doing. Okay, so in my slide, okay, I choose to use only 2 threads, but on 2 different nodes. So, oops, that's 2 MPI tasks, 1 MPI task per node, and 2 threads by rank. So indeed, you can see that I have 2 MPI tasks. So rank 0, rank 1. I'm running on 2 different compute nodes, number 92, 93, and for each MPI task, I have 2 threads running on 2 different cores. So to launch TotalView, the only thing you have to do, because TotalView is loaded by default by the programming environment, is to add TotalView before the APRN command and -a, so that TotalView know that everything which is after that is arguments for your executable. Okay, so in that case, everything is fine. And you click on Go, and it will ask you if you want to stop or not? Do you want to stop the job now? So here I will say yes because I don't have a bug in my example. But if you have a bug, TotalView will automatically crash, and you will be able to see where execution terminated because of the bug. But in that case, we don't have a bug, so I have to make the execution stop in a way. So I will put a breakpoint here and here, and then you start the execution. So as I said before, okay, let me go up. Here you have the list of breakpoints. I have 2 breakpoints. I have 2 processes, and for each MPI process, I have 2 threads. You don't care about the first line. That's for API. Okay, so you can examine the value of core ID, for example. In my case, for rank 0 and thread 0, it's running on the first core of the compute node, core 0. But if you want to change, actually, if you want to see the value, okay, let me just continue to the bottom of the program. If you want to see the value across processes for the rank, for example, just right-click and click on Show me the value across processes. And okay, so that's the value of rank for rank 0, which is 0, and the value of rank 1, which is 1 for rank 1. And you can do the same for threads. So you right-click and you show me across threads. And of course, you can navigate through the threads, so that's the 2 first lines are the first rank, and the 2 last lines are the last rank. So in that case, gives you an idea of what's inside the variable. What else can I tell you? Yeah, if you want to move from one process to the other, you just click here, and you see that here I am on MPI rank 0, MPI rank 1, same thing for the thread 1, oops, thread 3, which is kind of well, you can navigate, and I think that's all what we want to see for now. So we just kill the job, exit TotalView, and actually I will restart TotalView. Okay. I will just put a breakpoint here. So let's say you run until the end of your application, and then you click on Go. That will finish the execution. And actually, you don't have to restart TotalView if you want to restart. You just have to click on that button here, and it will begin from scratch. But it will keep all the list of breakpoints that you put before. So that's a way to save CPU time, because if you are using printf, every time you change something in the way you want to display variables, you have to recompile your code. So in that case, you don't have to recompile your code. Okay, it's almost time for you to work. And I'm still in an interactive session, so please don't forget to kill your interactive session, otherwise you will be charged on your allocation, on the allocation of your group for the time you spent doing debugging. So if at the end of the month you don't have any CPU time left, that's not my fault. But of course, we can also say that if you have very difficult problems with your code, you don't manage to debug it, we are here to help, so feel free to send us an email. Okay, back to the slide. So as Sadaf was saying, we can't use TotalView because there are too many people and not enough licenses. But after the course, feel free to use TotalView because it's really a nice tool. So for the moment, we will use GDB, which is open source tool, which is based on the same commands. So here you have the break command where you can set breakpoints. You have the info breakpoints. I will do a very short demo again. You have the help command, the run command, so you can see, you can start the execution of your code. You can even attach to an already running code. You can use step to advance in the execution of your code. The good news is that there are interfaces to GDB because that's a command line tool which is not very user-friendly. But you can, if you want to debug on your workstation and you don't want to buy the license of TotalView, you can use tools like DDD, which is a Linux application, which will more or less show you the same interface that you can get with TotalView. Or you can even use Eclipse, which is a even more user-friendly interface. And it's all free, open source. So you should be able to debug your code anywhere. Okay, another demo. So in that case, I will just reuse our example, but I will just use OpenMP because GDB doesn't support MPI. Actually, yep, sorry.
Could you change colors? So something like white on black?
Okay, you can do that. Yeah.
That's good. That's excellent. I like it.
I will try to read. Normally, you should be able to read the slides, so let me know if there is something not clear.
The previous one was better.
Okay, so we are going to do exactly the same thing that we did with TotalView, except that it will be the GDB on an OpenMP example. So let me show you the code again. I've put ifdef here, which means that we can recompile the code without MPI. You could also put ifdef for the OpenMP directives, but you don't really need to do that because in any case, the OpenMP directive looks exactly the same as a Fortran comment for the compiler, so it will just ignore it if the OpenMP compilation flag is not used. Okay, so let me recompile that thing. I'll just remove MPI. Let me go interactive, otherwise we will run on the login node, which is not what we want. And hopefully that should work. So of course, in that case, we have only one rank because we don't use MPI, we are on the same node, and we have two threads running on two different cores. So a way to check if you are running or not is to use the sq command, which is the equivalent of the qstat command. And in that case, you see that I'm running an interactive session, a bash session, and the time limit for interactive session is 1 hour, and I'm using one compute node. So the way to use GDB is just to add the GDB. Oh, I forgot to load GDB. If you don't load the module file of GDB, you will use the default version of GDB, which is not as good as the one from Cray. Okay, so we are in GDB now. You can see it's GDB version 7.2. So if you remember my source code, I can set some breakpoints. So I will set 2 breakpoints in that case, one at line 34 and one at line 45, which is at the end of the source. Then you start your application by typing run, and now it will show you the number of threads. So in that case, you have 2 threads. If you do info threads, so thread number 1 and thread number 2. The difference with TotalView is that GDB will run only 1 thread at a time, and with TotalView, it's possible to run all the threads together, so you have to be aware of that. And okay.
Where can you find the source files you are using?
We will have some exercise, so I will give you the files just after that, or because I will give you more difficult exercise than that. So, okay, if you want to see where in the code you are, you just do a list. So I am around line 34, and let's print the value of the thread ID. In that case, it's thread number 0, and if you want to move to the next thread, you just do info thread. If you want to know how many threads you have, then you can move to thread number 2. And again, if you print the thread ID, it should not be 0, it's 1 now. Okay, so that's a way to see the value of your variable during execution. And if you want to continue, just press continue, or actually you just press C, because GDB uses aliases. So now it's telling me that it moved to the thread number 2 moved to breakpoint number 1. So if I press again, it will take the last command. So in that case, I'm in breakpoint number 2. And of course, if you print the thread ID, it came back to the other thread, and you press run. Oops. Well, okay, it just crashed, but I think I show you what I wanted to show. And if you want to continue, just keep on pressing enter, and it will run until the end of the execution. And now I think it's your turn to play with the debuggers, unless you have a question.
It really looks easier than instance.
Yeah, well, it depends on the number of threads.